Warning: sodium cyanide is an extremely toxic poison. This experiment must be performed with gloves in the fume hood. This experiment also uses high temperatures. Fire safety protocols must be in place. This should only be performed by an experienced chemist. No, seriously, this is some crazy-ass lethal shit. If you screw up, you will die. I'm not joking around here. The only reason why I'm even doing this is because it's necessary to make the drug pyrimethamine. If you do not possess at least a bachelor's degree in chemistry, do not try this. Doing it is straightforward, but staying safe requires a safety mentality that you can only get with actual lab experience. Seriously, don't try this. Greetings, fellow nerds. In this video, we're going to make sodium cyanide. While it is famous as a lethal poison, it is tremendously useful in chemistry to manufacture other chemicals like nitriles. In fact, the reason why it became so famous as a poison is because it's used so much in the industry that it's easy to access and get poisoned both accidentally and intentionally. There are plenty of other, even more toxic chemicals, but they aren't used enough to become as well known as cyanide. I'll be using sodium cyanide to make a nitrile compound for making pyrimethamine. Now we're going to need moderately high temperatures for this, so we're going to modify our heating mantle we made in an earlier video. Rather than wrapping it around a flask, we're going to wrap it around a steel can. I'm using a steel can and not a beaker because we're going to melt sodium hydroxide later. Molten sodium hydroxide eats through glass, so we have to use a metal can instead. My heating tape is falling apart because I accidentally heated it beyond the insulator's maximum temperature. It's still good for another use, but I'm buying a new tape soon. For safety, my fume hood, stands, and other metal connections are grounded. Anyway, here is the fully assembled unit. It's darker in color than earlier because I was doing some heating as well as grounding tests to make sure it was safe to use. Let me switch over to the overhead camera since looking at it from the side is boring. Now to start, we add 100 grams of sodium hydroxide. Then we add 43 grams of cyanuric acid, which is sold as a chlorine stabilizer for swimming pools. Finally, we add 12 grams of carbon. Now give the mixture a good stir and slowly ramp up the temperature to 600 Celsius. Don't heat the mixture too fast or it will sputter. Go slowly over the course of an hour. As it starts to liquefy, occasionally stir to make sure there are no cold spots. As the temperature increases, the mixture may start to bubble. This is to be expected. First, the cyanuric acid and sodium hydroxide will react to form trisodium cyanurate in water. At these temperatures, the water will boil off. Then as the mixture reaches 550 Celsius, the trisodium cyanurate decomposes into sodium cyanate. This then reacts with carbon to form carbon dioxide and sodium cyanide. Some carbon dioxide will bubble out, but some will react with the sodium hydroxide to make sodium carbonate. There should be constant bubbling. If the bubbling goes too fast and threatens to overflow the heating mantle, then turn down the temperature to get it back under control. Eventually the bubbling should slow down and we can start raising the temperature again. Once we reach 600 Celsius without overflow, we continue heating for another hour. The bubbling should eventually stop. Then we turn off the heating and let the mixture cool. Now rather than cyanuric acid, urea can also be used to make cyanide as at high temperatures it reacts with hydroxides to produce ammonia and cyanate. This can then react with carbon to make cyanide as usual. Now we have our cooled mixture of sodium cyanide, sodium cyanate, sodium hydroxide, sodium carbonate, and leftover carbon. To separate them, we have to get them all out and dissolve them in methanol. The mixture is very hard like a rock, so I add the methanol directly to it to soften it and gradually break it up and scoop it out. Once again, I must emphasize you wear gloves and have safety precautions because this is a highly toxic solution of methanol and cyanide. So here's our mixture of methanol, sodium cyanide, and various byproducts and side products. Stir it up to break up the chunks into a fine powder and dissolve as much of the sodium cyanide as possible. I found I had to add more methanol to a total volume of 500 milliliters because the solution was becoming somewhat difficult to stir. Now once all this hard material has been reduced to a fine powder, continue stirring and start adding 100 grams of sodium bicarbonate. Add in small portions slowly so it doesn't clump up into chunks. What we're doing is reacting the sodium bicarbonate with some hydroxide and converting it to sodium carbonate. Sodium carbonate has low solubility in methanol while sodium hydroxide has high solubility. So by converting the sodium hydroxide into sodium carbonate, it can be precipitated out and separated from the sodium cyanide. After all the sodium bicarbonate is added, let the mixture stir for about half an hour. Now we filter the mixture. And here is our methanol solution of sodium cyanide. There's a small amount of very fine carbon dust and sodium carbonate and bicarbonate, but we can easily filter that again. Before we go further, we should test to make sure we really do have cyanide. Here is a freshly prepared solution of ferrous sulfate. It's very little, only about maybe half a gram in 10 milliliters of water. Now we add a few drops of the solution of cyanide and methanol to the ferrous sulfate solution. What we're trying to make is a substance called Prussian blue, which has a deep blue color. But Prussian blue requires both iron 3 and iron 2 ions. Since this solution of ferrous sulfate is fresh, it only has iron 2. To create some iron 3 ions, I just add in a few drops of hydrogen peroxide. Let me give it a shake. There we go, something is happening. Let me add in a few more drops of the cyanide solution. There we go, it's a very strong blue color. This is the pigment Prussian blue. And this proves that we have cyanide ions. So now I filter out one more time to get rid of the very fine particles. And then I remove the methanol by boiling it off. I'm distilling here because I want to reuse the methanol for future runs and because I want to reduce the air exposure. Air actually reacts with cyanide to convert into harmless cyanate. And here's our dried sodium cyanide. It's a bit impure with some sodium carbonate, but it should be good enough for amateur uses. And here it is transferred to some vials. My total yield was about 19 grams. This yield is about 36% based on the cyanuric acid. I can probably improve the yield by heating for longer, dissolving the sodium hydroxide and cyanuric acid together in water first, and then drying. And maybe using potassium hydroxide instead of sodium hydroxide because the decomposition temperature of potassium cyanate is lower than sodium cyanate. Oh well, considering how cheap the reagents are, I don't mind low yield as I can just try again on a larger scale to get more. I'm going to be using sodium cyanide to dissolve gold and do gold plating experiments. And I'll be using it as a precursor to make the drug pyrimethamine. The irony of using extremely lethal poison to make a life-saving drug is not lost on me. But chemistry is amazing like that. Oh yes, a word of note on waste disposal. Before tossing them out or washing them, soak the beakers, flasks, filter papers, and whatever else touched cyanide in liquid chlorine bleach for a few days. The sodium hypochlorite in the bleach oxidizes the cyanide into relatively harmless cyanate. Thanks for watching. If you would like to support the continued production of science videos like this one, please support the channel on Patreon. Links are in the video description.